Class, what's up? Welcome to our next video. Today we are focusing on a little bit of both section 4.5 and 4.6, and we have a lot of letters here, all S's and A's. So we're going to get into what all of these things mean. Basically, this video is going to help us prove triangles congruent. All right? We need to prove that triangles are congruent. Now, from 4.4, we said that for a polygon, or in our case right now we're talking triangles, for a triangle to be congruent, all of the sides and all of the angles must be congruent, okay? So recall that you proved triangles congruent by showing that all 6 pairs of corresponding parts were congruent. Now real quick, just so you remember, when I say 6 pairs, there's what? There were 3 pairs of sides and 3 pairs of angles. Well, I am here today to completely flip that upside down. Not really. Basically what we're going to do is we're going to give you some shortcuts, okay? From now on, I don't need all 6 pairs, okay? I don't need all 6 pairs. Maybe I need something like this first one, where I'm going to say if 3 sides of one triangle are congruent to 3 sides of another triangle, well then the triangles are congruent. So what I'm trying to get at here is there's a shortcut, right? I no longer need 3 pairs of sides and 3 pairs of angles. I now can say that if I see 3 sets of sides congruent, well, then we have congruent triangles. So we call that SSS for side, side, side. And this is kind of what I mean, all right? When we look at these two triangles, well, I see AB is length 4, DF is length 4. So what could I do? I hope you said you could make tick marks because those sides are congruent. And then I see BC is 6. Oh, what? DE is also 6, so I can do double tick marks there. And lastly, CA is 7, EF is 7, so I can put triples or any sort of tick marks to represent that those are congruent. And this is what I'm getting at now, guys. This is what I'm trying to say. Because I now have 3 pairs, 1, 2, 3, because I have 3 pairs of congruent sides, I can say my triangles are congruent. I don't need to know anything about the angles. Okay? So now, I would say triangle ABC is going to be congruent to triangle, and this is where you need to practice, okay? Needs to go in perfect order. Please note that I started at A, and I went down the side of the single tick mark, and then I went to the side of my double tick mark, and then my triple tick mark back to the original. So I have to do the exact same thing so everything lines up perfectly. So again, I started at this point A, the vertex between the first and triple, the single and triple tick mark. So that means I need to start there in the other triangle. So single, triple, A, single, triple, F. Okay, F is between the single and triple, so that's where I have to start. Now again, I went along the single tick, so I have to do the same thing in the other triangle. So F to D, and then of course I really only have one more point, E. But it should make sense because why? F is between the single triple, so is A. D is between the single and double, D's in the second spot. B lines up perfectly, they correspond. Lastly, C and E are both between the double and triple, which is why they should line up exactly in the same spot in our congruence statement. Okay, so that is a quick rundown of side, side, side. And now we have a bunch more shortcuts to go over and teach you. All right. Now, before we get into the next shortcut, I need to explain what an included angle is, okay? An included angle, which we see a picture for, we'll talk about it in a second, is formed by two adjacent sides of a polygon. Now, we're just talking triangles, right? So we're always going to have adjacent sides. These sides will always, whatever two you pick, will always be adjacent. But we call the included angle the one that's between the two that we care about. So, if I'm looking at this picture, I'm going to say B is the included angle. And what is angle B between? Well, it's touching side AB, and it's touching side BC. So B is the included angle between sides AB and BC. Now, we need that because our next postulate, our next triangle postulate, has to do with this included angle. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Alright, so we look at this picture. Oh, actually before, just remember the shortcut, the way we say it, SAS, SAS for side, angle, side. And now we look at the picture, okay? We have to recognize, well, I have one set of sides congruent, I have another set of sides congruent, and then what do I notice? A and E are congruent, and they are the included angles. So this is exactly what we're looking for. We now know that the triangles are congruent, and now we just have to write the congruent statement. So I like to write ABC just because it's easy for me, and it helps us figure out how to find corresponding parts. So in this triangle, please note, I started at A. I started at that congruent angle, or the marked angle. So if I started with A, then hopefully you guys agree I have to start with E in my next triangle. Now I went from A to B, so I went along the single tick mark, which means I need to go along the single tick mark in the other, and then there's only one option for the last. But it should make sense that ABC is congruent to EFD, and A lines up with E, B lines up with F, and then lastly, C lines up with D. Those are perfectly corresponding. Okay? Sweet. Moving on to the next page. Got a couple more things, and then we'll call it a video. Alright. Just like there is an included angle, there are also included sides. Okay? So we call an included side the common side of two consecutive consecutive angles in a polygon, okay? What do I mean by consecutive? Well, I just mean angles that are kind of next to each other, right? Now, for triangles, it's impossible. Just like included angle, when we talk triangles, all angles are always consecutive, all right? When we get into other shapes, we will see where angles cannot be consecutive. So, what I need you to understand here, when we look at this picture, P and Q are my angles that are marked, so what side is kind of part of both of those angles, or which side is touching both of those vertices? Well, it's PQ, right? PQ, this side right here, is a part of angle P and of angle Q. So PQ is the included side of angle P and angle Q. Now we need that because our next postulate has to do with included sides. If two angles excuse me, and the included side of one triangle are congruent to two angles and the included side of another triangle, well then the triangles are, you guessed it, congruent. So now we know that we have another postulate, ASA, or angle side angle. We're looking for two angles, two pairs of congruent angles, and then the side between those angles to be congruent. Okay? So let's take a look. I have two angles, and I have that included side, so perfect. Here we go. Triangle ABC. Congruent to triangle. All right, let's go to work. A is at my single arc, so of course that's going to line up with the single arc in the other. D. Now I went from single to no arc mark, so again I have to go from single to no arc mark, or E. And then of course we ended at C, which is the double arc mark, so F. All right. Okay. Last one that we're going to use for the time being. You guys can probably get an idea but from the words, but again, let's chat. All right. If two angles and a third, actually, what am I going with here? If two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. Alright, so this one is honestly not much different than the one before. You just have to be very aware that this one is angle side. So this is two angles, two consecutive angles, and then a third side, or the side, is not between the two angles. It's not included. It's non-included. Alright, so what do we see here? Well, I have angles, two pairs, right? I have two sets of tick marks, and then I have this side, and notice this side is not between my tick marks, or sorry, arc marks. This tick mark is not between my arcs. This tick is not between my arcs. So again, I'm fine here. It's just I have to use angle side, not angle side angle. Alright, so here we go. Last one, triangle. Okay, let's see. Let's go GHJ. Why not? GHJ. Doesn't really matter how you start as long as you line it up correct. So GHJ, if I start at G, or my single arc, that means I have to go and start at my single arc in my other. So triangle K. And then I went from G to no arc mark. So single to none, which means I have to do the exact same thing in the other. Single to none, or L. And then of course there's only one more option, and that's M. Now, this video, it's getting a little long. I do want to just add one more thing and kind of show you guys what I mean by this. You have to remember, as long as the parts correspond correctly, then I don't care how you list it. I did GHJ. Is everyone going to use GHJ? No way, okay? I'm going to try another, and I'm going to say instead of going GHJ, I'm going to go JGH. Alright? Now, I went from double to single to none, which means I need to go from double to single to none in my other. So M to K to L. M, K, L. Now, this is what I need you to understand. Whichever one you look at, or whichever one you end up doing, what lines up? Well, in my first one, J and M were both together in the third spot. And in my new one, J and M are still together. It's just they're in the first spot instead of the third. H and L are together in the second spot in my first conclusion, or first congruent statement. H and L are together again, okay? So notice, this means that these are still correctly corresponding to each other, okay? As long as H and L line up, wherever you put it, it is fine with me. Or same thing with G and K, or J and M. Alright, so I am done talking for now. We will practice some of this. I hope that you guys are picking up on this. I think conceptually this might be a little easier than marking pictures, so yeah, just keep working, don't give up, and make sure to ask questions if you need help. I'll see you next time. Peace.